Hey, what's up? I'm Will Button. This is DevOps for Developers. And in this video, we're going to talk about the CAP Theorem or the CAP Principle. It doesn't really get a lot of love on the YouTubes, but it's really important for you to understand as you build and design modern software architecture. So the CAP in CAP Theorem stands for consistency, availability, and partition tolerance. The CAP principle states that it's not possible to build a distributed system that guarantees all three. You need to choose up to two based on the needs of the application you're building. So let's dig in a little bit deeper into each of those three components to understand what they mean, and I'll give you some examples to show when they may or may not be important to consider. Consistency means that all of the nodes see the same data at the same time. What that means is if you have multiple replicas, like in a cluster of database servers, and there's an update being processed, all users see the update at the same time, even if they're connected to different replicas in the cluster. The opposite of this is sometimes called eventual consistency, meaning that all the replicas will eventually get the updated data. To understand why this may be important, imagine that you're at an ATM in New York withdrawing cash from your bank account, and at the same time your significant other is in Los Angeles, also at an ATM withdrawing cash from the same account. Now, without consistency, it would be possible for both of you to withdraw more money from the ATM than what was actually in your bank account. Now, while that sounds great for you, it's not good for the bank, who would in turn also make it not good for you by hitting you with overdraft fees. If we consider another example though, we can see where consistency may not be important. For example, if I edit this Wikipedia article, once I click on save, I can see the changes, but if it takes a few seconds for someone on the other side of the world to see those changes, that's completely okay. Now, availability is a guarantee that every request receives a response about whether it was successful or it failed. We can continue with our ATM example here and see that the ATM must have an answer from the bank before it can dispense the cash. Availability is usually accomplished with replicas, such as having multiple servers in a cluster so that there's always at least one server available to handle requests. And for what it's worth, an error message does count as a response from an availability perspective. Partition tolerance means that our system can continue to operate despite arbitrary message loss or a failure in part of the system. This can be a bit tricky to understand, so bear with me for a second here. Imagine that in our cluster we have multiple replicas, and each of the replicas communicate over the network with each other, and one of the replicas is designated as the primary. In the event that the network communication is interrupted between these replicas, the primary can continue to respond to requests, but we won't have consistency because the primary server is not able to communicate updates to the other replicas. When this communication breakdown occurs, it's possible for one of the replicas to take over as the primary because it sees the scenario as a loss of the primary server. Now we have a scenario with two servers that both think they're primary, each of them willing to write updates to the data. This is called split brain. One clever way used by MongoDB to deal with this is the primary server is not actually allowed to vote for itself. Only the replicas can vote to promote a replica to the primary. So let's wrap all this up by talking about some of the common database platforms and where they fall. Traditional RDBMS systems like PostgreSQL and MySQL fall into the CA category, meaning that they provide consistency and availability, but not partition tolerance. Databases like React, Cassandra, CouchDB, and DynamoDB are AP, so they provide availability and partition tolerance, but not consistency. Finally, MongoDB, HBase, Redis, and Memcache are CP, so they provide consistency and partition tolerance, but not availability. The big takeaway here is for you to understand that you can only provide 2 of 3 in the CAP theorem, and you need to ask questions to understand the requirements of the app that you're building in order to choose the right platform. If you want to learn more about DevOps skills and how they apply to building modern software architecture, be sure to check out the DevOps Roadmap. I'll put a link down in the description below for you. It's a choose your own adventure style guide that lets you focus on the parts you know and see how they integrate with the other DevOps skills that you may not know about. So thanks for watching, and I'll see you in the next video.